In this lecture, we're going to talk about haptic rendering. So the definition of haptic rendering is that it's the process of computing the force resulting from contacts with virtual objects based on measurements of the operator's motion. So this will be most clear if we walk through it with some pictures. So the idea is that the human is holding on to some haptic device, and I haven't drawn the entire haptic device, which would be over here, but the idea is that you're typically interacting with some kind of stylus that's connected through a mechanism to something that has actuators on the other side. And the human operator can move around the stylus that's attached to the haptic device. So the device will, with the sensors that are on the joints, will measure the operator input. And the idea is that that information will go into the virtual environment, which will record the user's movement. So the idea is that this programmed virtual environment, which is again something that you will program, will have a representation of this tool that the user is holding on to. And the programmed virtual environment will make it feel like you're actually pushing on some other objects. So let's say there are some blocks in the virtual environment. You would be programming or haptic rendering an environment that would feel like you're using the stylus to push on real blocks. Now, the input to this program is the measured operator motion, and then the output is the desired haptic display output, and that is typically going to be a force. So usually we're going to have a measure of position and maybe velocity as your measured operator input, and then force as your haptic display output. So the goal of all of this is to try to make it feel like the user is actually pushing on to these virtual blocks with the stylus. So although in the last slide the user is not really pushing on anything physical in the environment other than the haptic device itself, the user should feel as if they're connected to real objects. So this feeling of it being like you're connected to real objects is the idea of transparency, which means that the user feels as if she's directly interacting with the virtual environment. And this causes some challenge for both designing haptic devices as well as programming them. So she should feel like the environment is exactly as the designer or programmer intended. Sometimes those virtual environments will be very realistic, and sometimes they'll be purposely unrealistic. But no matter what, we want the forces or the force-motion relationships that the user feels to be exactly what we want them to be. And this means that the user doesn't feel other forces that might arise from the physical mechanism of the haptic device. So inherently that device is going to have some mass, it's going to have some friction, maybe even it will have auditory noise associated with its movements. But ideally, the user won't notice any of those things because those effects will be so small that what they'll only really be feeling is the virtual environment. And this gets back to some of the issues we discussed earlier about how you design a haptic device in order to make it as transparent as possible.